Title of the first section today is Solving Using the Square Root Property. In this section, we'll solve equations using a square root property. First equation is x squared plus 4x plus 4 equals 25. To solve this question, we can first take the polynomial on the left side, x squared plus 4x plus 4. This is a factorable polynomial. We can factor using the diamond or x method, where we have to multiply to get 4, and we also have to add to get 4. Two numbers that multiply to get 4 and add to get 4 would be 2 and 2. Rewriting the equation, using the factors of 2, we'll have x plus 2 and x plus 2 equals 25. Simplifying this, if we have the same parentheses, x plus 2 times x plus 2, we can rewrite that as x plus 2 squared equals 25. From here, we can use the square root property, which means we can take the square root on both sides of the equation, and the equation will still be equal. Taking the square root of an exponent squared would cancel, so we'll be left with x plus 2 equals the square root of 25 would be 5. Also, when you take a square root in an equation, x plus 2, instead of 5, it could be negative 5, because negative 5 times negative 5 would still be 25. Solving from here, we can subtract 2 on both sides. So x is equal to 3 for our first answer. And our second answer, subtracting 2, we'll have x equals negative 7. So our two answers to the equation, x equals 3 and x equals negative 7. Second question, and last question for the section. X squared plus 7x plus 49 over 4 equals 4. Solving. The left-hand side, again, this is a factorable polynomial we can factor. If you want to, you can use the diamond method. The top number that we're multiplying to is 49 over 4, and the number I have to add to is 7. Thinking about fractions that multiply to get 49 over 4 and also add to get 7, the two fractions would be 7 over 2 and 7 over 2. 7 over 2 times 7 over 2 would be 49 over 4, and if you add 7 over 2 plus 7 over 2, that would be 14 over 2, or 14 divided by 2 would be 7. Rewriting the question, we'll have x plus 7 over 2, and our second answer the same, x plus 7 over 2 equals 4. And again, if we have these same parentheses twice, we can write that as a single parentheses, x plus 7 over 2 squared equals 4. The square root property again, we can take the square root of both sides of an equation. If you take a square root of an exponent squared, those will cancel, and you'll be left with x plus 7 over 2 equals the square root of 4, which would be 2. Keep in mind, when you take a square root on an equation, we'll have a second answer, x plus 7 over 2 equals the other square root of 4 would be negative 2, since negative 2 times negative 2 would be positive 4. Solving these equations, we can subtract 7 over 2 on both sides. If we change 2 into a fraction for common denominators, 2 over 1, we can multiply by 2. So 2 is the same as 4 over 2. And we'll have our first answer, 4 over 2 minus 7 over 2 would be negative 3 over 2. or -3/2. The second equation, we can subtract 7/2 on both sides. This equation we have -2, so that would be -4/2. -4/2 minus 7/2. Our second answer would be -11/2 or -11/2. And those would be the answers to the equation. Title of the last section today is Solving by completing the square. In this section, we'll solve equations by completing the square, which is a factoring technique. The definition for completing the square: the value of c, which will be the last number of a trinomial. The value of c will want to be b divided by 2 squared, and we want the value a to be equal to 1. So c again, which is the last number in the trinomial, that will be equal to b, which is the coefficient in front of x, divided by 2 squared, and we also want a, which is the coefficient in front of x squared, to equal 1. First equation we'll solve is x squared plus 16x equals 36. To first complete the square on here, we'll rewrite the equation x squared plus 16x, and we'll add to that a number, leave a blank spot, equals 36 plus another blank spot, which would be the exact same number on both sides. To find the number to add on both sides, we'll take the value of b, which again in this case the coefficient in front of x is 16. We'll divide that by 2, and we'll also square it. 16 divided by 2 would be 8, and 8 squared would be 64. So 64, the value of c, is the number that will add to both sides of the equation. So the trinomial we have x squared plus 16x plus 64. This is a factorable trinomial. If you want to, you can draw the x or the diamond, multiplying to get 64 and adding to get 16. The two numbers that multiply to get 64 and add to get 16 would be 8 times 8. So factoring this trinomial, we'll have x plus 8 and x plus 8 equals 36 plus 64 would be 100. Solving from here, we have the same parentheses twice, x plus 8, so we can rewrite that as x plus 8 squared equals 100. Using the square root property, we can take the square root on both sides. The square root and the square would cancel, so we'll be left with x plus 8 equals the square root of 100, which would be 10, and our second equation, the second square root of 100, would be -10. Solving from here, we can subtract 8 on both sides, so our first answer will be x equals 2, and the second equation, subtracting 8 on both sides, x would equal -18. So the two values to the original equation, x equals 2 and x equals -18. Second question and second equation for this section. We'll have x squared minus 8x equals -15. Solving this equation by completing the square, we can rewrite the equation x squared minus 8x plus a blank spot, which will add a new number to factor, equals negative 15 plus again another number, which will be the same number we'll add on both sides. To find the number we'll add, you take the value of b, which is negative 8, divide by 2, and square the number. Negative 8 divided by 2 would be negative 4, and negative 4 squared would be 16. So we'll add 16 on both sides of the equation. Factoring, x squared minus 8x plus 16. 16 again will multiply 2, and negative 8 will add. Two numbers that multiply to get 16 and add to get negative 8. Those two numbers would be negative 4 and negative 4. When you complete the square, the original question after you divide by 2 will always be the numbers for the solution. Rewriting the polynomial, we'll have x minus 4 and x minus 4 equals negative 15 plus 16 would be 1. Simplifying x minus 4 twice, we can rewrite as x minus 4 squared equals 1. From here we can take the square root on both sides. So we'll be left with x minus 4 equals the square root of 1, which would be 1, and also x minus 4 equals the square root of 1, which is also negative 1. Solving each of these, we can add 4 on both sides. So the first answer, x equals 5. And the second equation, adding 4 on both sides, we'll have x equals 3. So two answers, x equals 5 and x equals 3. Last equation and last problem for the section. We'll have 9x squared minus 6x minus 4 equals 0. Solving this question, looking at the values, we have a is equal to 9, the number in front of x squared. Keep in mind we want a to be equal to 1 when we complete the square. To change this to 1, what we can do is divide the entire equation by 9. Dividing by 9, the 9's will cancel, so we'll be left with x squared. Negative 6 divided by 9. If we reduce fractions, that would be negative 2/3 x, and negative 4 divided by 9 would be negative 4 over 9. 0 divided by 9 would still be 0. So anytime we have a coefficient other than 1, you can divide by that same coefficient, so our coefficient now would be 1. To complete the square on this equation, we want to have the a and b isolated and